Good afternoon. Welcome to the last meeting of this year's monsoon. So this is going to be an overview of what happened this year. And till today, the latest update about an hour back, all India monsoon records crossed 900 millimeters. So it's, but it won't be a flood year. Remember about a month back, the way forecasts were going on, we thought maybe above 110. That won't happen. It's right now 7% above normal. It will maybe go to 7.5 or something, but it won't be flood year. But the most interesting thing about this year is all the 4 months of this year were above normal. It has never happened. In the 125 years of data that IMD has provided, there is no year of normal rainfall where all the 4 months are above normal. I'm surprised. I put the blame on global warming. There's a lot more moisture now. So a couple of months ago. So, and of course, the only thing here was Northeast. And this is the most unusual. Western India got 30% above normal, which no one predicted. So that is an interesting feature of that. But both Central India and South Peninsula are within the normal range, okay? Now, monsoon is withdrawing already today. It cloud gone past Delhi. So it's withdrawing gradually following the schedule. But it will have some more rain for the next 1 week, according to all the forecasts. As all of you saw in newspapers, there was a huge rainfall in Calcutta due to depression. And why I want to show you this is, in the 22nd morning, there was no rain. Okay? It started at 2:30 in the night, and it rained like crazy. That's why we have so much flood. The 250 millimeters, which is not a record, but occurred in a matter of 6 to 7 hours. Okay, so that's what caused so much problem in Calcutta. And this is not unique. Calcutta does get very high rainfall due to depressions every now and then. There have been records of 380 millimeters in one day 50 years ago. So this is not unusual. And, well, was it a cloudburst? Maybe, because there's such a high rainfall here. If this occurs in a 1 hour period, then they give you every 3 hours, then maybe it was a cloudburst. Okay, now we look at the cumulative rainfall till today. The important feature of this monsoon is this feature. Rajasthan, Gujarat, Kashmir, Uttarakhand, this one, all these got very high rainfall, and this east-west dipole is always there in the Indian monsoon. We all know that. And of course, Tamil Nadu are not supposed to get a lot of rain during some month. That's okay. But rest of India, this is above 60%. This region, okay, which is very high. It's not a normal behavior. Okay. Now, if you look at the distribution, that's also important. IMD provided the data for the last 5 years. You'll see that large excess, which is above 60%, only 10% of the district got it this year, similar to 2022, similar to, I would say, even like last year. Then you look at excess above 20% to 60%, same as last year, by the way. This is same as last year. And this also is very similar. Okay. So I would say in many respects, this year's monsoon is similar to last year, except that in last year, the June was below normal. Okay. This year, June was also above normal. So this year is unique that all the 4 months were above normal. Last year, June was below normal. It was made up a little later. Now, this is the all India distribution, except for a short period of first week of August, but there was a break-like situation. It was for about 10 days, but it was made up by, after a late onset in Central India, made up in June and July as well as August. Okay. Now, if you look at core monsoon zone, okay, and it's data available till today, 24. Again, you can see this was the only time there was a data for this one, but immediately weighted by rainfall, and so it's here. Now I want to show the result in a slightly different way. I asked Dr. Vaibhav, who is helping me in some of the graphics. He has got 15 years of data from IMD. I think this is rain gauge data correctly. And he plotted the all India rainfall having got 15 years. Okay. And I'm comparing this with climatology given by IMD. Okay. Now I'm surprised. I would have thought after averaging the 15 years, all these peaks would disappear. They have not. Okay. This is what asking how many years you have to average to get rid of the intercell variation. Looks like 30, 40, 50 years, looks like that. And but the key point about this thing is that you took a long-term mean, the rainfall starts in June 1st, linearly increases up to July 15th, remains almost constant, climatologically I'm talking about, and then decreases. Okay? It's a nice pattern like that. And you can get that 880 value by just assuming a linear function, not a constant value, you'll get the right answer for the climatological rainfall. Because of that, if you look at the climatological data of the Indian monsoon from IMD, you can almost predict that in 70% of the years, this is how it will go. First 100 millimeters occur in 22 days. The next one is a little shorter, takes about 13 days. Next is even shorter, 11 days. And 10 days, then this is again 10 days. This is 12 days, 13 days, and then 17 days, and then 16 days. It's very interesting that the climatological variation is so smooth in its structure, okay? And I believe it is related to the energy coming in, because without that, it cannot behave the way it's behaving, okay? And you're not talking about year-to-year variation, you're talking about the long-term mean, okay? Now, I asked Vaibhav to also plot what's happening in South India, average over 15 years. It's very different. South India, we start with a pretty high rainfall in June, and then it rapidly rises in July, which I didn't expect, because July I thought IISc will go north, and then it comes down in August, and then, so this is very different from all India. Okay? So we keep seeing all India, that is the average of all the regions, so it doesn't quite have the picture. So actually next year I will show you each region has a different character. But in average, all of them, all that disappears. Okay. And also, the color scheme, you use different marks, different scheme, it highlights the role very nicely. Okay. Now, one thing about the last 2 weeks has been a very poor forecast by GFS about 10-day rainfall. You remember early in the season it was going very good. This time, most of the time it's below, forecast is well above observation. Okay? Although it's able to get the decline correctly, but well below. And that's why, remember when I beginning September, I said this year may be a flood year because the forecast was all going 10, 12, 13, 14. Okay? It didn't happen. So all that was wrong. I would like to know why the forecast going wrong at all India level, which I think should have been quite good. And this is not just GFS, even ECMWF is orbiting rainfall. So I'm surprised by this because in an era where so much assimilation going on, so much of satellite, whatever data going in, how can you get all India rainfall wrong? So that is a question somebody has to figure out why it's something like that. Okay. Now, this is old, also same, it is not similar. And this is the last week. Again, you can see it's getting a decline correctly. But all the numbers are above what is observed. Okay. Now, if you recall, the next week, 22nd, 29th, we're already in that week now. According to ECMWF, there's a nice large scale picture which I'm already impressed by here, which is all the way across to Japan. And so that's why in the next 6 days, it's going to at least be 30 millimeters or 35 millimeters. So right now we are at 900 something. We'll go to 935 or something close to that. Okay. But will not be a flood year. Now, look at the forecast for the next 10 days. The most interesting is this part. So near the end, monsoon is giving a big kick, huge value on the last day. Now that's very interesting. So I looked at also Eastern developed, they also show that. And the reason is very interesting. The reason is because there is a depression in the Bay of Bengal, which is moving into India in the next few days. And that is shown by this nice map. This is an interesting website. I asked how we look at it. It's called Tropical Tidbits. A news website. By chance I got it. And he's I think a NOAA employee who on the side puts out nice software. Okay. So his forecast says it's a very 6-hour forecast. So I like to look at it to know whether it will rain in the evening. It's not daily, it's 6 hours. So he's showing that on 20th September at 5:30 a.m. the depression will be right over I think Andhra Pradesh. That's the prediction. Let's see. And that will increase all India rainfall because depressions do give very large rainfall. Okay. Now let me compare this year and last year because I'm surprised that the 2 years are so similar. Okay. It's very rare. Now these are all I think essentially want to be very similar. We have a negative PDO. Okay. Almost neutral and so. Okay. But 2025 was remarkable. All methods were normal. Not true in the case of 24. Okay. And this is the main difference. This was made up by August. Okay. So August this year we kept that because of that short break. In last year it didn't happen. But the final number I think was 188. I mean that's my guess. We're close to 188. And close by 9:30. Okay. So I just did that in the next plot. Okay. So you compare the different regions, the 2 years. There is a difference. The difference is here. Okay. I would say this is the biggest difference. So something unusual happened this year. I'll talk about that, the role of WBs here. It's caused the Northwest India to have extreme rainfall, which didn't happen last year. Okay. Now, the unusual pattern of rainfall this year is this axis. Okay. So I would have normally argued that this because depressions and lows were going up this monsoon trough. Partly it's true, but this year I think something else also happened in the interaction between western disturbances and depressions. Okay, but I want to note a very interesting thing. This is from NSUB analysis. Notice that this is a huge area of Arabian Sea. Now, this I find very interesting. Arabian Sea is the one which gives us moisture, the Indian monsoon, okay, but it has not much rainfall. Now, this is a bit puzzling. So I want to look at whether this is unique to this year. It was same last year also same. So I'm very surprised how the last 2 years had almost same spatial pattern, which is very rare when you compare year to year, okay? So we look at it again, there has to be a reason for it. Now and then IMD puts out some interesting data about heavy rainfall events. This from Andhra Pradesh in the last days of August, September. Now why I'm putting it out is that they are saying in Guntur, rainfall was 1,880% of the normal, okay? I think it's very misleading. I think it's not right to quote daily rainfall and a 2-day rainfall compared to climatology, because synoptic system will occur on different days in different years, obviously. Okay, so if you take a monthly mean, that one is very low. If you compare daily, numbers go up 100 times, 1,000 times. To me, it is one has to find some other way to show the anomaly. So this, of course, people who are in administration deal with floods, they're very happy to show this happened because not because of me. Okay, but from the point of view of statistics, I think this is not the right way to compare high daily rainfall with the kilometer mean, because in the mean, remember, in any given month, typically we have 10 days of rain during monsoon, not more. Okay, so if you average over a month, you are averaging 20 days of no rainfall also. So comparing the daily value with daily value averaged over climatology is to me somewhat confusing. Okay, now let's go to the main issue we discussed in the beginning of this season, how good was the long-term forecast of the mean rainfall of India? Okay. First, of course, is IMD. This is the IMD tertile forecast, which has no numbers, but just saying, I would say they are right. They said all this is above normal. I would say more or less they're okay. But this unusual event here is not visible here because it's only, little bit is less, not much. Okay. So I would say okay, but not that extreme rainfall in Rajasthan and Gujarat. Now you recall ECMWF in the month of May, they said June was above normal, they were a little bit above normal, August. So that is more or less right. It has come out pretty much right. Okay. But they modified it in, the most recent forecast, September 1st. I am showing you this only because, see the forecast for October. It's well above normal. Okay. So October is going to above normal, which is again an unusual event which is happening more often. Okay. Let's compare with Suman Degam's forecast, University of Maryland. We had a seminar by Agnes and Gupta on this issue. I would say they didn't get it right. They got this part right. Okay. This they didn't get right. They got something here, Gujarat is okay. But Rajasthan, Uttarakhand, their magnitude is wrong. Okay. So what is the message from Agnes' work is that method seems to get the spatial pattern roughly right. Quantitatively, they are way off. Okay. So obviously, SST patterns do govern spatial patterns, but they cannot give you the exact magnitude. So pure machine learning is not going to get anywhere to get the quantitative things correctly. Okay. Let's compare with NCRWF, June, July, August, September. I would say more or less right. Again, they don't get this part. This is the right pattern here. Okay. And Kerala also was below normal this year, so that's okay. Now let's do a review of the last 11 years during which we discussed about monsoon. And I want to notice that in every year except this one, at least 1 month was below normal, like this one was below normal, and of course, and then it was made up by another month. Like, for example, 2019 started very badly, but September made up for it. 2018 went well, and then September went down. So in all of them, there is some compensation by another month. 1 month not good. But as far as I know, in a year the rainfall is not a flood case, that is not 110%. All the 4 months above normal is exception. Okay. And last year one was below normal, and this made up. Okay. Now I looked at the entire data. Only 1 year I can think of. There's no year of normal rainfall. I can show you 3 or 4 years of La Nina, where all the 4 months are above normal, and to the flood year. Take 83 to 113%. Okay. But 83 was amazing. June and July were below normal, and then it picked up. And the reason was very interesting because June and July was a El Nino, August and was La Nina. It just plunged. And I don't know how many have studied that unusual feature that the La Nina transition, El Nino La Nina occurs in the middle of the monsoon. If that happens, you're in trouble. I don't think anybody can forget that. Normally it happens after the monsoon or well before the monsoon, but during the monsoon it happens, I think all forecasts are off. So 83 was a very unusual year, above normal because August and September more than made up for June and July. So there is no other year I know of where the final value is below 10% and all. So that's unusual. So I can only guess that because of the higher temperature and higher humidity that's prevailing now, this kind of thing may happen more often. Okay. Now let's look at IMD's forecast, which they made in the month of May. I would say this is very good because it's right in the middle of this there, all India. June, they said over 108, 109, that's not bad. August, I would say they are 100% really, even a range, 105. September, they said about 109, they are correct. But I'm not sure because we're not got the final result, maybe 109, 108. Okay. Then look at regional. This I'm not happy with because they give only one side. No forecast, you should have a range. I don't know why they give a. So this is, you'll always win this, unless you're really off. So they are right here, they are right here, they are right here, they are right here because one-sided. So I would not give too much credit, but this is quite good, these two. Okay. Now, IMD became very adventurous. Decided they'll make a forecast for the seasonal mean for all the 36 subdivision. I think that was not a good idea because I don't think these models are that good. Okay, and the news comes out very clearly. I cannot give you all the values. I just given you 8 examples. They are off in most cases, especially Rajasthan, they are way off. Chhattisgarh, not bad, but Kerala, they are completely off. This surprised me because Kerala has been having consistently seasonal mean rainfall below normal for the last 20 years. I don't know how the model forecast one, I don't know. Okay. And it was wrong in Northern Karnataka, it was so right for Kerala. So I think this is what I call bold venture, but I don't think our model is good enough to do that. I will next year I will look at it in more detail. But again, I'm unhappy about that because except for all the other one-sided prediction, which I think is useless. To me, you have to give the upper and lower limit, otherwise you're not making a forecast. It's like your astrologer saying you'll become rich. You have to tell me how rich I'll become. Okay, 1 rupee or 1,000 rupees. So it's a vague thing to say you'll be above this. So I hope they will change this thing. Okay, let's look at SkyMet, the private forecaster. They are also right except June. June they got it wrong, but July, August, September, I would say more or less okay. Now to me, all this is because of only one reason, the PDO. Okay, the last 3-4 years, PDO has been one sign, and it has a large SH anomaly over North Pacific, which has an impact which Aridham has looked at for June and July. But I think it is a large region in the Pacific. It will have an impact on the Indian monsoon. Okay, and if you look at this year's recent SH anomaly, this is huge. It's not minor. Of course, La Nina has become well developed. As a matter of fact, as of today, La Nina is not declared, but I won't be surprised by October, November, December, if the La Nina becomes strong, SH anomaly becomes stronger, they'll declare this year a La Nina. But as far as you and I are concerned, it's not a La Nina. So monsoon is over. If it becomes La Nina, it doesn't matter to us. But it is strengthening a lot. I'm sure it's going to happen. But look at the forecasts. Forecasts are pretty poor. Look at ECMWF. Half the forecasts are above, half are below. That was a neutral forecast. Okay. Now, if you remember, Rajendran gave a talk here in July about his CFS2 forecast. Again, same thing. Forecast showing half of half below normal. Only one ensemble, one number ensemble seems to follow the observation. Now, I'm really amazed by this because all these are few days apart, initial condition. So I'm surprised that small change in initial condition has such a big impact on an ocean parameter. Remember, SST is a very, very stable parameter. It's not like wind or moisture or rainfall. It shouldn't be so sensitive to wind conditions. So this is a bit puzzling. The only hint I can give you is one problem in the 3.4 region is that cooling is due to upwelling. Okay, upwelling is a very, very nonlinear phenomenon. It can happen over a period of 1 week if the winds are right. Okay, so it looks like the difficulty in 3.4 is because the upwelling in the Eastern Pacific, it is driven by very, very small differences. And when you have all these conditions, the winds in the Pacific are somewhat different and they alter the upwelling in the East Pacific. Now, this has been discussed. I'm not an expert in this. Vichy has written a lot of papers about the poor forecast scale of 3.4. He says we don't fully understand the physics. He's right. And high and low heat content, which we discussed, the water volume, necessary but not sufficient condition. Okay. So the biggest problem is that the transition from El Nino to La Nina is triggered by these winds, okay? And they only last a few days. That is where the uncertainty comes. So when you look at all the initial conditions that Rajendran gave, in some of them, westerly bursts occurred, in some of them did not occur. So that makes a huge difference. So that is where the, what you call, the nonlinear and a complex nature of El Nino should be understood, that it is because upwelling will occur, upwelling sensitive to the wind bursts that occur in the atmosphere. Okay. Now let's compare how Nino 3.4 and IOD varied this year. Notice that they were roughly constant from 1st June to around 20th July. And both of them started decreasing. The IOD plunged to minus 1.2. And this one has gone down, go further down, I think. Now, this is what surprises me. It has gone to minus 1.2. And if you ask anybody, it will cause a major impact on the Indian monsoon on the negative side, because the negative IOD. It has not happened. So I'm convinced that IOD impact on the Indian monsoon only occurs on the western side. It is the western equatorial ocean whose temperature controls the moisture coming to India. Eastern side does nothing. Okay? But remember, IOD is very important for Indonesia, for Australia. They keep looking at it because this will have an impact on the Australian monsoon in November, December, January. It's very important. Okay? For India, it doesn't be important. That's my gut feeling. Okay. Now, what's very interesting about this year? We thought of Nino 3.4 and IOD and so on, and PDO, but really Atlantic played a role. Okay. Now we have discussed this before the last 10 years. And so this year I'm going to talk more about it because it looks like it made an impact. Now, if you look at a correlation between ISMR and SSG all over the world, everybody highlight this 0.4, 0.5 correlation for this region. Okay. But hardly anybody highlight this. This is equally big. Okay? Not large in area, but it's equally big. And they make so much fuss about IOD. IOD is not that big. Okay. And to me, this should be given importance for another reason. Nino 3.4 peaks in December. Okay. That's why we have a problem, because during the monsoon we don't know it will be high or not. But this guy, the Atlantic Nino, its cold mode peaks in July. So to me, that's very important. If something peaks in July, it's going to have impact on the monsoon. Okay. But people have neglected for following reason. People have studied the fluctuation of the Atlantic, equatorial Atlantic region called ATL3. I'll show you the region. It was quite high in the southern region, then it went down. So people thought it's not any more important. I think it has come back, looks like, in the last 10 years. Now, what is interesting about the season cycle of the Atlantic Nino, equatorial one, is that the warming occurs in March, April, and then the cooling occurs in July. This is what is important for us. If in this phase, this is very cold, it makes the monsoon above normal. Okay? That is the key point. Now, this is one way to show it. I like the other way. They have shown a series of cold events and warm events. Okay. The cold event is colder than normal in April and continues to be much colder in July, August. Warm event is warmer and then remains warmer. Okay. So we'll focus on this. But this year, this was the condition. Okay. So right in April, we could have guessed that there is going to be a negative phase of the Atlantic Nino. Okay. So here are two phases, the cold phase and the warm phase, and we focus on just around the equator. Okay. Now, so a lot of papers appear in it, but not too much in my given. One is by Yadav from IIT Pune. He has done the EF of this SSP and linked it to the Atlantic, the first PC to the Atlantic, and shown this feature. I want you to look at this feature. This is very special. When this is warm, there's a drought along this line. And this cold, exact opposite. You'll see that. Okay. So this is unique signature which has not been discussed at all. Okay. Now, how was it this year? This year was quite cold, above minus 0.5 in a very large region of between June and August. And interestingly, even last year was like this. Okay. So I'm again trying to tie in the last 2 years being similar. Now they are similar because both were negative PDO. In both, there was a hint of a La Nina, but it didn't quite happen. And Atlantic was also below normal. Okay, all the three happened together in both years, which I think is very rare. Okay? So both these years were like that. That's why. So now people define different indices in the Atlantic, like in the El Nino region. So one is called ATL3, which is very similar to this, except you use 3 south and 3 north, why? But this Atlantic zonal mode is defined as twice of 3 north and this. I think there's not much difference. They are in June to August, which is where it peaks. Okay. Now here is one paper by Sabir Ali, in which he shows that the observed mode here, correlation, during a warm phase will be negative, and 12 of the 18 all correctly get this, 6 don't get it. Okay, so that's one thing. Those who are doing research in this should ask yourself: is your model correctly getting the AZ Atlantic zonal mode or not? Okay. Now, what's good about this paper is there was one more paper published by the same group. They compared cold minus warm, okay, which is what is relevant to this year. You can see this high rainfall, positive, 30 millimeters per month, right from Rajasthan to Orissa. Okay, so that is absolutely close to what is this year. But I want to warn you, 30 millimeters per month is fairly large. This one, but remember, this is because they make cold minus warm. If you do cold minus just the climatology, then you got 50 millimeters. And that's what mostly in this region will spike, okay, for the month of June to August.
But it is not getting the Kerala rainfall.
Huh?
Kerala
Yeah, Kerala drop. I tell you, this one, the thing we are seeing both from Agni Gupta and here, Kerala rainfall is determined by orography. They all get it wrong. You have to get your wind speed right, wind direction right. So most guys, we saw somebody pointed out last time also that for Kerala, Agni Gupta's prediction is exactly opposite. Yeah, so let's focus only on this. So this is not driven by something else.
Yes,
yeah.
Lactic acid is the path of the depression. Source and depression go from.
Yeah. It looks like that, but that's a further complication. Yeah, I would say this year, this year and last year, lots of low sentiment went up. Yeah, that's right. But how does Atlantic affect it? I don't know. See, this is a problem with this. A lot of people have done work based on the correlation, but finally, the exact mechanism which causes Atlantic Indian monsoon is not clear. I'll show you a cartoon. Okay. Now, this I like because this is very close to what we saw this year. Okay. Very, very close. You can get a better match and last year. So I would say that there's clear proof that the Atlantic cold mode did have impact in this monsoon. Okay. How it is not clear. In the paper by Yadav, I think that's the paper Yadav, right? Yeah. He has published many papers. He has various pathways. Okay. Now, this is typical in meteorology. You do a lot of correlation analysis and few things, then you make a grand theory with no facts to support it. Okay, this is a very nice picture, maybe right, but I don't see quantitative demonstration of how this cold thing affected that. Okay? There's a mention of kill mechanism and so on, but the only way to do that would be to run many simulations with that model and show the path. For example, this is where I like what Dipanjan has done. He gave a talk last year. You have to look at the path by which the moisture is coming to India. Okay, so you have to ask yourself, if this is cold, how does rainfall increase in India? Where is the connection? Okay, these connections they are drawing They are cartoons. They are not real explanation. And they have to demonstrate by running the model in very different ways to show what's happening. Okay. As a matter, I remember one of the papers we saw a couple of years back, professor from MIT, he basically put a barrier to prevent this happening. It's a little artificial, but it's very powerful. You have to prevent that moisture from coming there. Okay. Now, let me come back to the second important issue this year, other than the Atlantic Nino, is the Western disturbance. Okay. Now, we don't discuss it at all in our forum because it doesn't happen normally in the monsoon time. And it is very common in winter, and it's very simple and what do you call line of rain which moves across North India every year, every week or so. It's extremely common, extremely simple. It's not a deep convective rain. It's a beating of cold and what do you call dry air with warm and moist air. So, but it looks like this year there was interaction. Now, the one problem I have is that IIMD does a very good job of putting all the tracks. Okay, you see so many tracks this year. Okay, all coming from here. Okay. Now, there are 6 of them. I wish they had done a similar track for the WTC. Unless they put the track and I see the tracks approaching each other, I don't believe they interact. Okay, so I think you'll see it next year, I'm sure, because normally IMD's approaches during the monsoon, they don't do too much analysis. For the monsoon is over, they do a very thorough analysis. I'll show an example of last year. So I'm sure next year we'll know more about whether WT is better or not. So this is this year, this is last year. So both had 6 lows and depressions, which cause heavy rainfall. So both years show a lot of similarity. Okay. Now, why we don't know, whether it's Atlantic Nino or something else, we're not clear. Now, I talked about this earlier in this discussion about the work of Hunt, which is the most thorough work, scientifically rigorous one, in which he has tracked every WD over the last 50 years, okay, using ERA data, okay, ERA file. Now, his focus was on winter, because majority of WDs are in winter, okay. So all your things here you can see well above India, okay. And a few in June you'll see. And it's shown where the CGs. Now, so from there you can see that most of the WD intensity measured in what is the values, mostly it is here. And it sort of comes out in big resolution. This is winter. Okay? It's not done in summer much because there are not too many of them. That's the problem. So he has done the whole cycle which I talked about. The problem is in summer, it's very small. Okay? As far as the intensity, this intensity, this is very large in winter, okay? Potentially wise. In summer, it's hardly there. So to talk about WTs in June, July, August, and there are 3 or 4, it's not easy compared to 15 in winter. Okay? But I'm sure that in the next few years, a lot of people work on it because there is a hint that the two are interacting. Okay? But one surprise is that in the work that Hunt did and looked at the future, looks like they're going to decline, okay, due to global warming. Now, I pointed out that polar region is warming a lot, so the gradient between 30 north and 8 north is going down. So there's a feeling that WDs will weaken. Okay, but if all of you can see in the last row, the last 10 years it is not like this. You see, these are actual data we have. They've gone up. Okay? But in the long term, it's supposed to go down. That's what from 2 different versions of single file. Okay. Now, in the recent paper by Hunt, he says Western disturbances in June are now twice as frequent as they were for most of the 20th century. That means earlier it was 1 or 2, now it's 3 or 4. That's what it is. Okay. So there's a risk of, I think it's a very important point. Because of global warming, Arabian Sea is much warmer. If some of the air from the Arabian Sea gets into the WTs or into the difference coming from Bay of Bengal, it will provide more moisture to the system. Okay. So Hunt's argument is typically it is northward, there's a measures by the time we come to May, but now it's not happening. It's hanging around in June over India. That is, so it's trying to arrive during the monsoon. That is the main point he's making. I think he's the only expert in the field now. He's only published 4 or 5 papers, and I hope more people get involved in it because it looks like it is a novel phenomenon. Okay. Now, Depanjan had an interesting paper published, I think, earlier this year, comparing the 2 heavy rainfall events in Uttarakhand, the one famous one, Kedarnath, and one in July. And I like it because he uses Lagrangian approach, which I think is the only way to understand physically what's happening. And he shows that they are not same. In June, indeed, WT is interacted with whatever happened here. These are trajectories here. While in July, it is mostly from Arabian Sea. Okay. So his argument is that extreme events in Uttarakhand are not all similar. Some are in the WT, some are not. Okay. Now, this is what I showed earlier. I'll repeat it. So Hunt has a very nice cartoon showing 4 different ways in which the tropical depression can interact with WT. Okay. But I want to use the cartoons. He has not actually gone into details of how they interact. He talks about 4 possible ways. They look interesting. It's worth pursuing this further. And those of you who like synoptic meteorology should do analysis. And I'm sure this can be done very easily with WRF. We don't need a big GCM. Okay. These are short events, 6 days, 10 days. So you can take a WRF and run it and see which of these things are happening at what time. Okay. Now, in the paper he published this year, he made a very interesting point that IMD has always been saying that all the moisture for the WT comes from Mediterranean Ocean. But with the isotope analysis, he is able to show that it's coming from Arabian Sea. That's a very important conclusion because Arabian Sea is warming rapidly. It's a large source of moisture for the Indian monsoon. So the combination of increasing temperature in the Arabian Sea and the changes in the location of the jet can have impact on WT in summer. Okay. Now let me show you 2 examples from last year. Okay, because IISc publishes a very, very detailed account of every event after the monsoon, not now. Okay. So last year's data. Last year there was a depression which went all the way from Madhya Pradesh all the way and went up to Uttarakhand. Okay. No, Uttar Pradesh. Now here is where I don't quite agree with that. Their argument is that this depression should have gone this way, but because of WT, it went that way. Okay. They may be right. So they are all experts. I'm not expert. But I would like them to demonstrate by running a model. The whole purpose of model is to test a hypothesis. You cannot just make a hypothesis and run away. Okay, you have to show what it is. So maybe we can think about running a WRF model in which WT is there, not there, the depression changes the direction. So their argument is this particular depression normally should have gone this way. It went this way because there was everybody sitting there. Could be right, but it's worth further. The second thing is more interesting. Yeah.
Reanalysis also should show that, right? I mean,
Yeah.
Go back and look at the reanalysis.
Yeah.
Also shows the nature of western disturbance. And that could easily be checked, right? You don't need a right?
You're right. But only advantage I would say in running a model is you can change the SST, do anything. Yeah. Reanalysis, by the way, entire work of Hunt is reanalysis. Hunt has 4 or 5 very good papers. And I'm surprised that nobody in India did some work on that. But otherwise, the really thorough work was done. British was sitting in university reading, okay, which is amazing, okay. So it's all based on reanalysis. Entire analysis is all reanalysis based, yeah. So the next one they talk about, which happened in what is this month? Yeah, next. Okay, in December, okay. So, later part, okay? Here they are saying something interesting. Here the depression didn't change direction. They are saying it slowed down because of WT. Very interesting hypothesis, but no proof. Okay. Now let me tell you, WT makes the depression go slowly. It is very bad for people because there have been cases in the last 150 years when a depression from Bay of Bengal did not move for 3 or 4 days and create large-scale havoc. Once a depression doesn't move, you're in trouble. Okay. It is just a system that goes on putting rain for 3 days. It has happened in Calcutta before, it has happened in other places. So if they are claiming that this one slowed down, it came rapidly here, then slowed down, and it was WT, it's an interesting point of view, but I would like to see a proof that the rate of movement of depression is related to WT being there or not being there. Okay, that's a point I would like somebody to look at. Okay. Now, that complete discussion of this year's monsoon, and since we have come to the end and we are allowed to speculate, I would like to speculate what will happen next year. Okay. For speculation, only one basis, El Nino, nothing else. Okay. So look at IRI prediction. IRI prediction, the dynamical model, which I think more reliable, says that by May, June, July of 2026, we will approach 0.5. Okay. Close to El Nino. Okay. So there's a possibility that it could be either neutral this year, next year or El Nino, one of the two. Okay. Now, what is the forecast coming from IISc? IISc predicts July, August, September to be 0.5. Okay. With a large, I want to look at this error bar, it is this large. Okay. It could be 1, it could be 0, we don't know. Okay. Now, if you look at their ENSO probabilities, what is interesting is 50% chance of El Nino, 50% chance, which is very high. Okay. So next is going to be interesting. If the La Nina develops further and in December it's a La Nina, then we have to look at Arindam's classification. It will go from La Nina to neutral or La Nina to El Nino. Okay. So just so happens, just a week ago, an interesting paper appeared in which all the big names, Mark Kane, Adam Sobel, all the big names are there. And Science, I want to look at it. This is essentially continuing the work done by Arindam's group, along with Nikom as well as Nirupam, in which they showed that heavy rainfall occurs during breaks in the monsoon. Okay. So this is a continuation, but I want all of you to look at this paper, available for free. And the key thing is the kind of statistics they use. Very novel. I want it's worth understanding how they do it. So there are a lot of smart guys in that group from IRI who are good in statistics. So they adopted a novel statistics to bring out the role of extreme events. So I want you to look at that. Okay. Now let's look at the prediction of ECMWF. Even also says that it will be 1 degree. Okay. So a lot of people are now talking about El Nino next year. So we have to look at this possibility here. We may be either in a La Nina going towards El Nino, or neutral to El Nino, or neutral to neutral, or La Nina to neutral. All the possibilities are there. So one of them will occur. And for that, we have to go by the paper that Arindam published, showing the various probabilities. So it's going to be interesting. So we'll see what will happen next year. So before I close, I want to, if anybody wants to add anything on any other point. Yeah.
Is the connection to SST,
Huh?
the connection of monsoon to SSTs in specific basis?
Yeah.
Looks a little bit shallow to me. Rather than there should be a global mode, I think that makes good. I mean, what should
No, it's not. All I tell you, specific the most important is not the
that is true,
but
but
it's so small.
generally when you have an
Yeah.
you also have a person in Ocean there. I think part of
Yeah.
generally,
Yeah.
and similarly, the employees, yes, are also, I think, Atlantic billion is.
Yeah.
So I think, I mean, one can always understand what is the role of the sector being that. But I think they are all still, connected.
Because who is the actor, who is the follower? Because
I would think, yes, but.
I would argue specific is the actor, because that is the person in the world.
Yeah.
It doesn't. Or who is to play games with the whole.
But then there is no reason to, it's a house, the other places are responding to.
Yeah.
That.
Right.
So they all.
I don't think a good point made. The Atlantic line, now people are saying, is driven by IOD.
It may be.
Yeah. So it's a.
So there is.
That's true.
Yeah, I mean, okay.
But to me, the major story is in the economic. And when it comes out, it will drive everything.
Yeah.
Right?
That's fine. So I think there's no reason to, getting people connecting to the, let's say, IoT or, Atlantic, rather maybe they are part of this, they are.
You're right. That's why I like this because approach and we call it a seminar. Because they look at everything everywhere. But what I don't like is the machine learning approach, that box. You don't know what's happening. What makes it working up to a point?
Yes, topics like imagining, is the.
But the point is, they have been now, I can tell you, I like simple models. But I'm honest, simple models will not work in their topics. The model is very complicated, there are many interactions. Simple model only takes you so far, it can't do anything. But if you're going to use machine learning and all the data analysis, then you are.
Then you understand. But I think I always get puzzled by this, people looking at anomaly in one batch, anomaly in another.
Yeah.
Instead, at least with the topics, I think when you have, I'm sure there is a specific pattern that can be used in Indian Ocean as well as Atlantic. So what you're really thinking as a single mode in the tropics, SST anomaly, single mode.
Okay.
Yeah.
But what people have tried all the time, you have done so much, not quite come out as a single group.
Yeah, I think, in general, what I find is when you have, generally there is a possibility of positive here. And, Atlantic, I mean, average, I'm saying, because the magnitude could change, because the system is not less. But generally, I think, on an average, these three things are kind of, they come together.
But tell you why, it's not a single paper showing global prices. Huh?
Relation.
Yeah. Okay. Yeah, anybody else have any comment?
Okay, I just wanted to know, you have talked on the Atlantic node, and quite a few of these western disturbances also kind of job originating near Africa and Europe. So could there be a connection between the two of them?
But how to look again, the other paper, the other, and both, look at it, maybe yes, know something there. But I couldn't figure it, that's how, everybody said the best is that, that's what they all say. But I'm somebody does a model and shows what the changes are not. But yes, I think others argue, that's what it is. You see all the parts are shown. Only to middle of it.
There are 2 points we need to make, that whichever forecast is right or wrong, I think we should also associate those forecasts that right or wrong, especially if it's right. The reason why it was. Because several times, for example, let's say IMD may be right or wrong this year because it did not happen, or it did not happen, because they are predicted anything. And the second one is that you should verify the forecast from some independent source as well. That's the satellite data. We have fairly long time series of satellite data. But satellite rainfall. What I mean is that because I think this is very, it's becoming more.
I know it. That's around.
No, but see, from 1998, we have train data, and then IISc data has been converted to the trims algorithm. Isn't it also, trims algorithm or something? So we have pretty much sufficiently, and then IIMT's climatological band is also 30 years. Last 30 years, for example. So we have enough long data set to have an independent direction. Now, satellites sometimes overestimate, underestimate some estimate, that's okay. But we are within that band. At least we know that because reindeer themselves are not exactly accurate. There is so much of variation in terms of spatial condition, algorithm problem.
But I know, why can we can't go to.
No, it can, because we have seen that because IMD's year range, this report does not match with their predatory report.
Okay,
Doesn't even match.
oh,
Okay, so
what the correlation like? Yeah,
correlation is different. For example, last year, IMD said 108 or some 106%. I think the predatory report is some 110 or 12%, something like that, 12%. So there are large variations several years. I think end of the season, this anyone can have an error.
that's why we don't know that. And when they give the auditor report and the fund, they put error bars. The data has got error bar, right?
Yeah, but that is much,
Huh?
that is much less because finally they will say I have observed it and that's an error in kind of error in terms of the interpolation, for example. So that is a much lower error.
Yeah.
Only when if you compare with another data set, we know the variation. Otherwise, maybe.
Yeah, but unfortunately, it's not like data, that it ultimately is validated by the engagement.
That's true. No, that's the reason they are doing
But
it.
not independent.
But not independent, but that has been tuned in the past, right? So this year it is they have not tuned it. And when we are dividing by the mean,
Yeah,
then we should, it should at least show the anomalies. That has exactly happened. Isn't it? It should match the anomalies of greater and that's what the point is. Like climatically there may be some point,
yeah,
but the anomalies should match.
okay,
Okay, thank you.
yeah.
This year you showed the large ban
Uh,
which goes from India to Japan.
yeah,
Is it IISc or what, or exactly is
it's
this?
like,
Is it IISc?
it looks like that, but I can tell you that people have done analysis of this kind of features. It looks like one of us, it looks like that. But I'm not, the first time I'm seeing this in FMWR, so I look at it more and find out where FMWR. Yeah, looks like it's a connected thing all across. Okay, so I want to add on a lighter note. In the last few days, there a few things which I thought people now, the younger generation who are depending on AI and ML should look at it. The first thing is interesting. While language models hallucinate, okay, please read this paper because AI models can give you absurd answers. Okay, the word hallucinate is a bit crazy. They don't go mad, but they come up with solutions which are not real. Okay, so this group has suggested some way to fix that. Okay, the other one is from Wall Street. How to make sure ChatGPT doesn't make you dumber. Okay, so all of you use ChatGPT, be careful. Don't depend totally on it. So it's a good article. And then I want to thank Sujata, Anand Gaga, Samudra, and Abhishek for conducting this so well. And for the graphics, Dr. Weiber from Art Park helped me a lot. So thank you. We'll meet you on 3rd June. Thank you.